Business analytics uses data and tools like statistics, visualizations, and predictive models to help organizations make better decisions. It takes raw data from sources like customer interactions, supply chains, finances, and social media to find patterns, trends, and insight. This helps business improve operations, serve customers better, and stay competitive. This study focused on understanding how certain factors called independent variables impact a business outcome. Using regression analysis, it aims to identify key factors that affect results, test ideas about these relationships, and provide useful insight to improve business strategies and performance. The process involves collecting reliable data, ensuring its accuracy with tools like Chromebook Alpha, and then using regression analysis to find the most important factors. This will help business make better decisions and improve results. The study will provide practical examples of how to use business analytics to solve real problems and offer ideas for future research. In short, business analytics helps organizations use data to work smarter, and this study aims to show how it can be applied to achieve better outcomes. In our study, the independent variables are factors intentionally manipulated to observe their impact on outcomes. The first variable is task nature, which refers to how tasks are executed, understood, and approached. This includes aspects like the type of work, creative, analytical, or procedural, difficulty level, required skills, resources, time constraints, and expected outcomes. Understanding task nature helps allocate resources effectively, set expectations, and adopt the right strategies to achieve goals. The second variable is technology features, which are the attributes of capabilities of a technology, such as user-friendly interfaces, real-time data processing, customization options, and platform integration. These features define how technology functions and its usefulness. Knowing this helps individuals or organizations select the most appropriate tools for their needs, ensuring better performance. And the third variable is task technology alignment, which ensures that the chosen technology effectively supports the demand and goal of a task. Proper alignment results in a smoother workflows, higher productivity, and better results. However, poor alignment, like using unsuitable or outdated tools, can cause inefficiencies and frustration. Aligning the task with the right technology ensures optimal outcomes. And finally, student learning outcomes are clear statements describing what students should know or demonstrate by the end of a course or program. They guide instructors in focusing on critical learning goals, setting expectations, and assessing outcomes. For educational institutions, SLOs help evaluate program effectiveness, ensuring students gain the knowledge and skills needed for success. Together, these variables and outcome highlight the importance of aligning tasks, technology, and goals to achieve efficiency and desired results. In this study, data was collected from 76 participants through a well-organized survey designed to gather consistent information from everyone. The participants were selected from various demographic groups within the University Malaysia Perlis students to ensure diverse perspective on laptop use and satisfaction. This diversity allows us to understand user experiences better and identify unique needs such as professional prioritizing performance and students valuing mobility. By including feedback from a wide range of users, the study provides credible and applicable findings for different user groups. This approach gives us a comprehensive understanding of how laptops are used and what makes users satisfied, offering valuable insight into the needs of different categories of users.
Descriptive task nature (TN). The descriptive statistic for the task nature variable based on 93 respondents scored the range for 1 to 5, which means between 3.97 and 4.24, indicating the favorable perception. No standard deviation 0.83 for 1 to 1.092 suggests a consistent responses, particularly for the TN4. Sweetness and accuracy confirm the clustering the higher ratings. Next, technology feature (TF). For technology feature, mean score for range for 4.11 to 4.27, which TF rate the most probably low variability is standard deviation 0.846 to 0.931, and the strong agreement in evidence as shown by the negative sweetness and positive characteristic value. Third, technology element TTA. Technology element achieve a mean score by 4.06 and 4.35, reflecting the positive agreement. The higher rates item is a TTA 4. It has the lowest variability, indicating the consistent rating. Sweetness and characteristic trend support the observation of the clustering higher rating. Final is a student learning outcome SLO. The student learning outcome means score of 4.08 to 4.35, which is SLO 4 rate as highest. The SLO 4 also shown this variability, indicating the consistent responses, while distribution are slightly sweetness toward the higher rating, and data show the general agreement on the positive learning outcome. Next, test and analysis. Using the one simple t-test will compare the mean score of student learning outcome and task nature, the technology feature and technology alignment against the test value of 0. All variable is demonstrated the statistic significant result p less than 0.001, which mean different above 0 and 95% confidence interval excluding 0. This support the hypothesis that these variable are significant greater than the mu value. The reliability and this reveal the task nature. We calculate that alpha equal to 0.806. Next, technology feature, we calculate alpha 0 equal to 0.842. Next, technology alignments. We got alpha equal to 0.8844. A habit the good to the high reliability, whereas student learning outcome, we got alpha equal to 0.003. Show the full reliability necessitating scale redesign of the assessment.
Regression analysis is a method we use to study the relationship between our independent variable, task nature, technology feature, and task technology alignment, and the dependent variable, the student learning outcome SLO. It helps us to understand how these factors influence the outcome. From our analysis, the R2 value was 0.124, meaning that the model explained only 12.4% of the variability and SLO, showing limited predictive power. Among the predictors, technology features had the strongest but still statistically non-significant influence. We also observed multicollinearity, where predictors were highly correlated, making it difficult to interpret their individual impacts. This highlights the need for better predictor selection and model refinement. In conclusion, while regression provided some insight, improving the model and including more predictors in future studies could enhance its accuracy and usefulness for decision making. Lastly, this assignment shows how task, technology feature, and their alignment impact student learning outcome SLO using business analytics. We found that the independent variables were rated positively, but the regression analysis had limited accuracy with an R2 value of 0.124. Technology features were the stronger factor, but not statistically significant. This means aligning tasks with the right technology can improve outcomes, but better tools are needed to measure this impact more accurately. Future research should address this gap to make business analytics more effective.